Good morning, everyone. I think we've clicked over 11 o'clock. Warm welcome to everyone that is joining our next webinar put on today by NAFAs. We always have a great number of registrations for the more technical kind of webinars that we offer, and today's no exception. I think broken some records today with the number of people that have expressed interest in attending today. So there's a lot of people to log in. So we'll just give them another few seconds to get on board. But welcome to everyone who has joined us on time. All right, let's kick off. So welcome. Today's topic is addressing the recent changes that have been implemented to AS 1668, which is the mechanical ventilation in buildings and also natural ventilation. We have two key experts that are going to do the presentation today, and we're very grateful to these guys as we are with all our people that join and present for NAFAs. I think they do a great job of being able to distill what is often huge amounts of information down to a nice kind of summarized version for the rest of us to be able to understand it in a bit more layman terms, and then to be able to go off and research what's going to truly impact our businesses and our areas that are important. So today's experts, we've got Brett Fairweather, who's a director and a consulting engineer at a company called It's Engineered. And we also have Marcel Heijnen, who is manager of kitchen ventilation products at Stoddart, whom we all know. So a big thank you to those two guys. I will hand over in just a moment. Before we do, to avoid people jumping off to other meetings at the end, mention a few events that NAFAS is hosting and conducting over the coming weeks. The first one is our next AGM is being held on August 20. So any NAFAS members, please come along. It's an online meeting. You'll have a link already, and if you don't, please contact Jennifer. The industry dinner, our annual dinner that's conducted on the Monday night during Fine Foods. It's a massive event. We are quickly selling out. There are still some seats left. It is held on Monday, the 2nd of September in Melbourne, of course, with Fine Foods at Zinc Restaurant at Fed Square. So it'll be a great event. Again, contact Jennifer for details. And our final remaining CFSP course for this year of 2024 is being held in October 21 through to 23. So most of that is sold, but there are a few places. So jump on and secure any seats for CFSP. So enough of that. Let's back to what we're all here for today. So I would like to warmly welcome our two expert presenters, Brett and Marcel, and I hand over to you now. Thank you, gentlemen. The format for today, there will be questions at the end, so please put your questions into the chat during the session, and we'll address those with some time at the end. And if everyone can please remain on mute so that we can get through without any distractions. Off to you, Brett and Marcel. Thank you.
Thank you, Michael. Thanks for the introduction. Thank you for having me here to share a little bit about what we're all going to be learning about the application of this standard. So today's one of the early presentations after this has just been published, where we're, as a whole industry, we're going to be coming to terms with what's in this standard. So, it's a bit of a journey we're all starting together here. So I'll be introducing a bit of information about the standard, and then handing over to Marcel, who will get into some more of the detail around the kitchen ventilation and the like. So, yes, thanks again for having me along. So, not going to talk about myself much here, but I'm Brett Fairweather from It's Engineered, as has been introduced there. So I'm a mechanical engineer working as a consultant in the heating, ventilation, air conditioning industry. I'm also involved and have been since about 2011 in the various committees for the ventilation standards. So AS 1668 Part 2 and 4 that we're talking about today, but also I'm the current chairperson of the AS 1668 Part 1 and a number of the related sort of details there. So I'm just one of the team of volunteers on those committees, as Marcel is. So just sharing what I've learned along the way based on that sort of experience. Enough about me, though. Into the details here. So we're looking at the AS 1668 series, particularly focusing on AS 1668 Part 2, which is the mechanical ventilation in buildings. So natural ventilation and also issues of fire and smoke control are dealt with in other parts of the AS 1668 series. So just some general introduction, a bit of a disclaimer about what we're looking at. So the revised standards were prepared by a committee, like I say, a committee of volunteers, which superseded the 2012 editions of both 1668 Part 2 and 1668 Part 4. What we'll be looking at today is a bit of an introduction to the changes that are likely to need your awareness and your due consideration. But we do need to stress that this presentation doesn't identify every change. The content of the standards isn't what we're presenting today, and it's bound by copyright laws. You'll need to read the actual standard for the actual requirements, because those requirements overrule anything that we're going to be talking about today. So we're really just trying to express our own views as committee members and just to help you on your journey into understanding these revisions. So 1668 Part 2 and 4 were published only just at the end of June this year, so very, very recently, and that followed a process of drafting, public commenting, public resolution processes where the industry was given the opportunity to see what changes were coming, and based on information that came back, the committee spent a lot of time going through those, where the comments were within the scope of what we were tasked to present. That has actually influenced the final polishing of the standard before it was published. And look, this process will continue for years to come with future editions of the standard. So the updates were included to improve users' ability to conform with the requirements, making it harder to get it wrong, I think, is sort of where a lot of our focus was. Reducing ambiguity and reflecting contemporary technologies and practices. So recognising that things have changed a lot since the previous edition of the standard, and this edition should better accommodate a number of those changes. The standards were prepared in accordance with the agreed scope. So we had a very limited amount of work, or limited areas that we could work on. And it has been prepared for reference in the National Construction Code, the NCC, in the next edition of that. Which was also recently out for publication, but we're expecting it to be published and kick in, depending on how each state adopts it, on 1st of May 2025. So these standards have been produced to fall in line with the requirements from 1st of May of 2025. But the standard exists now, and there's an opportunity to be using that as part of performance solutions in new designs. So the reference documents schedule that was presented in NCC 2025's public comment draft identifies that the new revisions of 1668 are in there. So it's been demonstrated that this is intended to be referenced for 2025, and it will come in through the deemed to satisfy pathway through the regulation, which I'll explain in just a minute. But what is 1668 Part 2? It sets out the minimum design requirements for mechanical ventilation in buildings. It was first published back in the mid-1970s, and then has subsequently been revised in 1980, 91, 2002, 2012, and now in 2024. The requirements of the standard are built on these principles of dilution and filtration, which I'll give you a bit of an outline on in a minute as well. And these are prepared with consideration to the health and ventilation amenity for the occupants. The standard relies significantly on the use of outdoor air to displace and dilute indoor contaminants. The ventilation rates required by the standard exceed the minimum amounts that we need for just general respiration, general breathing, and are based predominantly on achieving a level of amenity that is acceptable to the majority of occupants within a space. All of the requirements in the standard, as I've mentioned, will continue to evolve over time in response to feedback from the industry and industry knowledge and changing technologies and so on. So just touching on that third point there on dilution and filtration, what I'm talking about there with dilution is flushing out contaminated air and replacing it with something that's deemed to be cleaner, typically air from outside. In most cases, we expect that the air outside the building is acceptably clean. Filtration can also be used to capture targeted contaminants, not just some other random unrelated contaminant, but capturing targeted contaminants from within the space, and that is going to reduce the reliance on the dilution process. So instead of just flushing out the contaminants, if we can capture some of them first, then we don't need to dilute the rest of them as much to get the same overall effect. So these are the basic principles that remain the basis of what's in 1668 Part 2. Just diagrammatically, just stepping through some of that, there's some slides that I've used to explain this over time. If we've got a space occupied by somebody, if we bring in a whole lot of outdoor air, it's just going to dilute the contaminants in the space. And if we keep flushing that air through there at the same rate it's being generated within the space, we achieve a level of equilibrium that's satisfactory for most occupants most of the time. That's what we're targeting with dilution. We can also dilute with extraction, where we will take air out of the space, and as long as we have a deliberate source of makeup air from an acceptable source, which is how AS 1668 requires it to be set up, then we're going to get a similar dilution effect to what we would have if we were supplying the air directly from outside. This just gives us a different balance of pressure relationships between different rooms to contain some of the odours and contaminants. When we're not just relying on dilution, we can use some filtration, and the purpose there is to take some air from the room, pass it through some sort of filtration device that will capture some of the contaminants from the room, and then we don't need as much outdoor air to dilute it. So there's some energy saving opportunities when we're pursuing systems that are set up like that. So compliance with AS 1668 Part 2, compliance with the NCC, which will reference 1668 Part 2, is described in the NCC and under clause A2G1. So use of 1668 is not mandatory, but the alternative might be a bit more complicated, but just give you an outline of the pathway through the NCC for compliance. This is a diagram out of the NCC, figure A2G1, which shows us that we've got, first of all, we've got the performance requirements. Now, these are mandatory. There's no exemption for this. We must comply with the performance requirements. But the building code that the NCC gives us options, two options. We can use a performance solution or a deemed to satisfy solution. These are both considered to be equally compliant. A performance solution involves a lot more input up front, but can give you a better and more efficient, perhaps lower cost outcome for the actual construction. So the performance solution involves extensive consultation, analysis, evaluation, and there's a final report with minimum content that needs to be produced. So it goes into a whole lot of issues there that need to be properly understood before you just head down the path of a performance solution. But what we're going to focus on today is the deemed to satisfy solution, which is the building code identifies AS 1668 Part 2 as part of that deemed to satisfy pathway through the code. So looking at some of the changes in 2024 edition of 1668 Part 2, some of the main technical changes. There's a big focus on removing non-quantified terms, which were considered to be quite vague and very difficult to demonstrate that something had actually been achieved. So they were replaced with quantified requirements, something that can be measured. Minimum outdoor air flow rate calculations are now presented in both simple and detailed formats. Doesn't change a lot around how the things are going to be achieved. It just makes it simpler to navigate your way through parts of Section 2 for that purpose if you're just heading down the simple path. Residential exhaust ventilation has now been aligned with what was already mandatory requirements of the NCC for condensation management. So there shouldn't be conflict there. Ventilation rates for car parks were reduced significantly, which has been aligned with the contemporary Australian vehicle fleet. And kitchen exhaust has undergone a number of updates, contemporary practice and technology, requirements are removed that belong and exist in other standards, like some of the fire safety requirements that belong in and already exist in AS 1668 Part 1. So there shouldn't be an overlap so much with fire safety requirements now, without changing the level of stringency, just not overlapping between the different standards. And there's a new compliance pathway for some types of treated effluent, which we'll talk about all of these things a bit later on. Healthcare ventilation is another part of 1668 Part 2 in Section 5. It's been updated and expanded for contemporary practice and technology in the healthcare space. Some notable general content revisions. Once you're reading the standard, you'll notice that the styling is a little bit different, just in line with the most recent Standards Australia document styling. There have been a number of editorial and technical errors that have been corrected, that have been discovered over time, predominantly from feedback from the industry. So feedback's very useful for the committee. Adoption of proven methodologies and technologies, standardise some common performance solutions. So where the performance solutions and all of the upfront work that I spoke about before has been used repeatedly with successful outcomes, there were obvious opportunities to bring that into the standard so that there's an easier path to compliance with proven strategies. So it's a good step forward, I think. We've removed some outdated and out-of-scope references from the standard. So there were out-of-date codes and standards, so the likes of some filters and refrigerants. So we needed some updates there. Also removed clauses and requirements in the scope and other standards, and not for the scope, that weren't related to the scope of mechanical ventilation, just clearing things up a little bit. There's also what I think is a significant amount of clarity in the text and the figures and the commentary. The commentary has been expanded quite a bit to really guide us through the use of the standard and what's intended. But I need to note that the use in the standard of figures, commentary and informative appendices are only in there to guide users and improve understanding. It's important to understand the written clauses in the text are the actual requirements. So particularly where you see the content written in a commentary box, which is in italics with a C in front of the number of the clause, that is just guidance. And you'll see there are some fairly vague terms in the descriptions about something that should happen or should be considered. They're just guidance to help us understand how to apply what's intended by the actual clause. Okay, so there's less uncertainty. There are more prescriptive requirements. Terms like reasonably uniform, reasonably accurate representation, as far as practicable, nuisance. These are all terms that are very difficult to quantify and point out on a page and say that's not right or that is right. So now these have been replaced with quantifiable and measurable criteria wherever we possibly could throughout the standard. So there's less ambiguity in what's required. Looking just briefly at each of the sections in the standard, just to give you an outline of what's happened. So when we're looking at section 2, which is for the supply systems, predominantly bringing outdoor air directly into spaces, there's some changes to intake locations. So there's now measurable separation distances rather than just requiring an assessment of the suitability of the source. Outdoor air calculations are resolved into simple and detailed procedures. So there's a bit of a choice there. There's also, in addition to the simple and detailed procedures, there's an option in there for borrowed mechanical ventilation. Those of you who are familiar with the borrowed natural ventilation that's permitted in the building code will understand the concept of this, but 1668 Part 2 has managed to adopt this as an option for mechanically ventilated spaces. It's quite limited in its application, but it's a bit of a start in looking at just some sensible approaches to areas that might not always have been easy to ventilate in the past. Filter efficiencies, there are now more choices in the type of filters that are available. In addition to the AS 1324 references, there's now an ISO reference and an ASHRAE reference that have been added in readiness for AS 1324 being superseded down the track. There's some more guidance on population indicators for demand control ventilation, which is where we actively modulate the amount of outdoor air coming into a space based on the number of people that are in the space. Appendix A, which sets out air quantities, outdoor air quantities being introduced into spaces, is a much bigger list now. So there's less uncertainty about how much air needs to be supplied to certain spaces. It's quite well aligned with spaces that are described in the building code as well. When we get into section 3, that's identifies where hoods are required, and there's a much clearer and, well, it's a more lengthy list of the type A and type B exhaust type contaminants in there to help us understand when we need to have hoods. There's some clarifications in kitchen hoods and cooking type processes. Grease removal devices have been consolidated. So where we previously had grease removal filters and grease removal devices in the appendices, that's been consolidated into the one requirement. So we've got a bit of a consistent approach there. Horizontal kitchen exhaust treatment method has been introduced in some very limited applications, but it's a start, adopting proven technology, which can be used for applications up to 5,000 litres a second. Previously, there was no permission in 1668 Part 2 to have horizontal discharge of anything over 1,000 litres a second. So this is just acknowledging that there are ways of achieving this appropriately. Section 3 defers existing requirements relating to fire safety to AS 1668 Part 1, which already deals with things like spark arrestants at the source. So that doesn't need to be repeated and dealt with differently in Section 3 anymore. And there have been some significant updates to Appendix B, which is the amount of air that we exhaust from spaces when's required. But there's more on Section 3, which Marcel will be going into later on, so certainly I don't want to dive too far into any of that here. Looking at Section 4, which is where we're dealing with vehicle enclosures, predominantly car parks. The car park ventilation scope has some commentary in it to highlight that it has nothing to do with electric vehicle charging. There's electric vehicle charging in car parks. The designer needs to refer to the charging appliance manufacturer for the ventilation requirements relevant to what's going on there. This has never been a standard that deals with charging of electric vehicles. It's a different application. The standard also doesn't deal with these automated vehicle storage systems. Some of you may be familiar with where cars are automatically stored, where there's no engine operating and there's no people in the car, where that function is not what we consider to be parking. So it's outside the scope of the standard with how that type of space is ventilated. There's also been some confusion that's evolved through the industry, particularly with those automated vehicle storage systems, which have become known throughout the industry as car stackers. There is a term stack parking that exists in the 2012 edition and previous editions of the standard, which related to the sort of the end-to-end parking within parking bays, where you may have multiple engines operating at the same time while you're shuffling cars around. We've replaced that term with tandem parking just to avoid some misunderstanding. It was never intended to extend to those, what we now call car stackers. Car parks, the full ventilation rate has been reduced now down to as low as 1,000 litres a second, depending on the design circumstances. Larger car parks with different applications and things will need some more, but that's the bare minimum now. That's come down from 2,000 litres a second in the last edition. We allow different usage factors per zone in the calculations now. So if you had an entire car park floor of a commercial car park and an entire car park floor of residential car park, then those zones, the movement of cars in those zones can be considered differently now rather than just having to take the worst case. When we're dealing with car lifts, where a car will drive into the lift with the occupant, the engine potentially running and moving from one floor to another, there are some clarifications around how they need to be ventilated appropriately. Then when we look at Section 5, which is to do with healthcare, there's some consolidated details. So we pulled all of the information relating to HEPA filter specifications and door opening forces, which were included previously, but described a little bit differently in different spots. We brought them together so those clauses can just refer to a single consistent reference there, just clarification. There's some general alignment with the Oz HFGs, the Health Facility Guidelines. So we've got some consistent terminology, some updated air changes and air distribution requirements. And for those of you with an interest in the healthcare side of things, Please understand that when we're looking at air change rates in healthcare facilities under 1668, those air change rates are for particulate arrestants and not for infection control. So that infection control issue needs to be dealt with separately, and there'll be health guidelines and the like to deal with those. There are clarifications for ventilation, filtration, and exhaust positions for each of the types of enclosures within Section 5. There's also 3 new enclosure types in the standard on the screen there now. Okay, so that's my outline of the standard. I'll be hanging around to help Marcel answer some questions a little bit later on, but I'm going to pass over now to Marcel to get into some of the meatier details of the kitchen exhaust system. So, Marcel, if you want to pinch the screen share, over to you.
Okay, I think I've got the screen, correct?
I think that's still mine there. And I'll stop sharing and let you grab it directly. Looks like that might be yours now. No. Is that yours now, Marcel?
Okay, you've got that now. There's my screen.
Yeah, I can. Yes, can see your cursor moving around. It's all yours.
Excellent. That's the transition part done. Okay, I'm going to talk to you a bit about kitchen exhaust systems, and typically it happens in a kitchen where there's cooking appliances, which in the standard are referred to as apparatus. Involves kitchen hoods, supply air, exhaust air, and discharge locations. The kitchen exhaust is covered by the NCC in section part F6. That stays the same in 2025, so in lighting and ventilation. There are 6 performance requirements in that section, and 3 of them pertain to ventilation. And in summary, they really focus on maintaining adequate air quality, controlling the odours and contaminants, and creating no undue nuisance and hazard. Those performance criteria are all qualified statements, not quantified statements. And they can be achieved by a performance solution or following the deemed to satisfy methods. The NCC also has 12 deemed to satisfy provisions in part F6. 2 that I'd like to draw your attention to, D6, which is ventilation of rooms, and it pulls into reference the mechanical ventilation of buildings and natural ventilation of buildings, the 2 codes that have 2 standards that have just been published, and the D12, which is the kitchen local exhaust ventilation, which pulls in as 1668.1 for fire and smoke control in buildings, and again the 1668.2 mechanical ventilation in buildings. So focusing on 1668.2, section 3 in the exhaust systems, it looks at general and local exhausts, the replenishment of that exhaust air, and the discharges. So focusing on the local exhaust ventilation, it describes type A and type B effluents. Again, for the purpose of kitchen ventilation, we'll focus on type B effluents, which looks at cooking and dishwasher equipment. To remove the qualitative statements out of the standard, the exemption for apparatus that does not cause objectionable solutions was removed. That was one of the notes in there, and in its place has been added a quantified provision for small single-phase cooking in large rooms. So not using the Australian standards words, but in principle, you all know that in a room with a single apparatus, If it exceeds 8 kilowatts or 29 megajoules, it's considered a type B effluent. What's been added to that is 3.6 kilowatt if it's a deep fryer. So previously, any deep fryer had to be treated as type B. So now small deep fryers are considered as excluded. In a room with multiple apparatus, again, the density of the cooking apparatus, less than 0.5 kilowatts per square metre, has been deemed acceptable from a ventilation perspective. And for small plug-in type appliances, if they're spread around the room, it's okay. If they're closer than 2 metres apart, then they're considered type B effluents. And any cooking apparatus fueled with solid fuel is also considered a type B effluent. So just some examples of those are a food product demo in a supermarket. They're not going to be able to put in a kitchen exhaust hood for it, so they might have a small fryer, countertop fryer that they're doing some demonstration cooking with. That's not considered a requirement for type B. A convenience store with a plug-in toaster or a cooktop or a small fryer that's used sporadically, or a breakfast room with conveyor toasters spread around the room. Obviously, if they collect all those appliances and put them all side by side, they become a significant load on the ventilation system and have to be considered as type B. But whilst they're in different parts of the room, they have a low impact. Some under-counter appliances fall into that too, like glass washers and under-counter ovens. So focusing in on 3.4 kitchen exhaust hoods, the design side of it, this standard has a simple method in clause 3.5 and Appendix E that looks at the airflows calculated by a fairly simple formula, which is the airflow times the open perimeter of the hood times the height above the cooking surface, and a V value, which previously was a number. So for fryers, you're all familiar with 375. The formula's being changed slightly in that 1,000's been added to the formula and the numbers have been dropped down by an order of magnitude, so that it's 0.375, which represents the average velocity through that open area of the perimeter times the height. There is also a more detailed method which conforms to proven standards represented in clause 3.6, and it allows airflows to be calculated by heat load calculations. Obviously, to do that calculation, you need to be aware of the equipment that's going in underneath the canopy, and you also need to know about the room, or the enclosure that it's going into. So VDI 2052 has been the standard method that's been adopted in the previous standard. The EN standard and the ASHRAE standards actually draw upon the VDI standard and put some extra details into their methods. ASHRAE with the proven hood efficiency, or proven hood effectiveness method, which is proven through the standard test methods, F1704. So just to highlight that, the thermal plumes calculated by the equipment. The flush out factor is a factor of the room, how the air is behaving in the room, whether it's laminar or mixed. Hood effectiveness factor is an ASHRAE factor that defaults to 0.7, but if you have higher efficiency built into the hood, that factor increases. And then, of course, if you're inducting air as part of that process, then that has to be calculated as part of your exhaust quantities as well. So it's more complex, and it requires more knowledge about the equipment and the environment in which it's going in. The simple method in the standard doesn't take into account how much equipment. It just looks at the process type. So whether it's one fryer or 4 fryers underneath the appliance makes no difference. It's just recognising that it's a hood for fryers. In addition to that, there's a proprietary exhaust allowance, which provides a requirement for airflows for apparatus that are fitted directly to the exhaust system. So an oven or the likes that has a direct flue connection to the kitchen exhaust, the airflows for that have to be nominated by the manufacturer of the equipment, and there must be a grease arrestor or grease separator in the junction between the appliance and the flue. And thirdly, if the effluent can't be prevented from escaping the opening, so that the door of the apparatus, then it will still require a hood. Hood overhangs. There was a conflict between section 3.5 and Appendix E with dimensions, and that has been removed. And in its place, a table has been added to section 3.4.3, table 3.1, process type hood overhangs. It has the front overhangs and side overhang requirements listed for different types of apparatus. 3.4.4 looks at the condensate hoods, or the hoods over dishwashers and the likes, and it's been revised slightly to clarify the application of reducing the 0.3 metres per second, 0.1 metre per second, and it looks at the overhang being measured horizontally from the openings of the appliance and measured from all sides of the appliance. So that is changed as well. So there's 7 types of hoods that's retained, that was carried over from the previous standard. So I'll just run through those 7 just to clarify them. So the first one is a low sidewall hood. So typically in your McDonald's and Hungry Jack's and the likes, with fryers, they have low sidewall hoods over them, which are enclosed. So they're very much like a fume cupboard in a laboratory or an industrial environment, where the air, replacement air is drawn in through the front, and the opportunity for escaping emissions is restricted to that front area. So the formula using the Australian standard again uses the height from the appliance to the entry, and because the ends are closed, the open perimeter is simply the front, and then the velocity is taken from the table. Corner and sidewall hoods, I group them together because a corner hood is effectively a sidewall hood where the mid-wall is the full length of the side. Again, it's measuring the open sides of the hood as the perimeter, the height above the cooking appliance, and then the factor out of the velocity out of the table for the inward airflow through that open area. In the appendices, Appendix E, these diagrams are carried over, and to avoid conflict, rather than having dimensions in those diagrams, have been replaced with variable. An island canopy is obviously got open sides on all, open area on all sides. So the perimeter is the entire way around, still the height and the velocity through that. In an island, it becomes critical to have a balanced room, because if you don't have a balanced room, you'll get air drafts, and the fumes, emissions being blown sideways outside of the hood, obviously is not going to be able to be captured. So it's got to be a balanced room with appropriate air supply. The 5th type is a ventilated ceiling, and there's various ways of doing ventilated ceilings. They allow for a larger open space and a good working environment for the staff. The replacement air can be either brought in from the ceiling or from low side walls, but it opens up the space. An eyebrow, and the eyebrow has always been number 6, but it never had a diagram previously. So it has a diagram added to show, again, the height of the opening is from the centre of the door, and if there's a flue, it must come into the canopy as well. And the 7th one is proprietary equipment. Proprietary equipment are items that are directly connected to the exhaust system, and they may be through a flue in the top, or they may be through a capture tunnel at the front. They may involve filtration at the unit before it gets into the ductwork, or they might be built around an appliance and connected to the exhaust. The cooking process types, there are 8 cooking process types. I'm sure those quickly. There were 7 previously, and they haven't really changed other than the description now focuses on what the requirement is rather than the examples. There are examples still listed in the standard underneath each of these. And probably the 2 to focus on are type 2 and type 3. They previously were almost interchangeable. So type 2 is now focusing on grease with not much steam, so induction tops and the likes, whereas 3 is focusing on steam and grease, so kettles and the likes. Your open fire pits, actually in type 4, it's worth noting that electric fryers were type 3 and gas fryers were type 4. All fryers are now categorised in type 4 as emitting high levels of grease. Type 5 is your open barbecues and char grills and the likes. And then type 6 is high levels of grease vapours, so WOX. 7 is your releases of large surges of contaminants, which is your combi ovens and large upright ovens. What's been added is type 8, which is emits embers and smoke. It, for all intents and purposes, was in type 5 and it's in type 5, except we wanted to really develop a focus on the management of embers. So process type 8, to clarify, it includes open flame grills and enclosed ovens. It does not include electrical gas heat ovens that have a small amount of moist smouldering wood purely for flavouring, where that wood is inside a spark arresting device, so in a cage or the likes. The overhang requirements for process type 8 are same as type 5, 300 mil from the surface. But if the cooking surface includes an open door, so if they're cooking on a hot open door, then it's from the perimeter of the door. Also, if the fire pit is lower than 900 mil off the floor, then the overhang has to be increased proportionally. So if it's at 800, it's 100 mil lower, so it's 100 mil you have to add to the overhang. Clause 3.4.6, as Brett advised earlier, has been removed. It is a requirement that looks at the fire and smoke control in buildings and therefore belongs in AS 1668.1 and has been removed from 1668.2. And finally, the process type 8 is deemed to contain objectionable effluent. So in clause 3.10.3, we look at the requirements. 3.10 looks at the types of effluent, and an objectionable discharge is defined in the table. And these are my words, but it effectively represents the table, where any flow rate from a type A is considered objectionable, and any flow rate for process type 8, so this solid fuels, is also objectionable. If the airflow is over 1,000 litres per second and it's not treated in accordance with clause 3.10.4, treated or not, over 5,000 litres is considered objectionable. So in summary, if it's not type A and it's not type 8 and it's less than 1,000 litres or it's less than 5,000 litres if treated, then it can be deemed not objectionable. The separation distances for not objectionable discharges is in the table. Used to be table 3.4, it's now table 3.5, and the table's been amended. It has minimum horizontal distances from its discharges to outdoor intakes, to property boundaries and natural ventilation devices. It has a minimum vertical distance to 4 levels of thoroughfares and occupied areas, and they are both in the table. And it also identifies that if the airflow is more than 400 litres a second, it must be directed away from an outside area. So if you're discharging 800 litres a second horizontally out onto a walkway, you can't, or a outdoor sitting area, you have to direct it away from those people. So section 3.10 had a commentary section at the end of it, clause C310(3). It was commentary only, but it was more and more accepted into performance deemed to satisfy pathway for treating objectionable type B effluents, which allows kitchen exhaust airs to be deemed not objectionable and then discharged accordingly. Obviously, anything over 5,000 litres and anything from large char grills and woks or from solid fuel apparatus needs detailed assessment of the contaminants and the outdoor environment, and that would be through a performance solution. So you can still look at treating those and going a different path than the straight objectionable things to satisfy method, but it would be a performance solution. So the treatment for the deemed to satisfy method involves progressive high performance filters. So there's an EPM 10 and EPM 1 requirement performance filters. So the old F4 and F5 and F9 methodologies, measurements are being adopted into the new ISO requirements, and there must be activated carbon to absorb odours, and they must that must be of a quantity that provides adequate exposure for absorption. In that system, there's a focus on the kitchen exhaust hoods. They must have grease removal filters that have an efficiency of at least 80% at 10 micron when tested in accordance with BDI 2052. Okay, so just jumping into Appendix E. The slope of the internal faces, which was 30 degrees off vertical for filters and 40 degrees for other faces. The other faces have been relaxed to 60 degrees from vertical to fall in line with what is fairly commonly practiced in the market in performance solutions. So it's being adopted into the standard. The height in trafficable areas was always a minimum of 2 metres, and that continues. It was a maximum of 1,200 mils above the cooking surface, which became ambiguous when you have different appliances of different heights. So it's now fixed at between 2 metres and 2.1 metres, or if you have very tall apparatus, 150 millimetres above the apparatus. So if you have a 2.1 metre tall oven, obviously you need the hood to be above it, but you don't want it a long way above it. Grease filters and removal devices, as Brett mentioned earlier, has been consolidated. There were two clauses or two sections in the appendix. They've been brought into one. The 30 degree from vertical for mesh and honeycomb filters remains. However, baffle and cyclonic filters, the angle has been aligned with the international standards from where those filters are often drawn, which is 45 degrees. The distance from the grease removal device to the heat source, that clause hasn't changed in that the distances haven't changed. There was a conflict in there in that the title said to a heat source and the text said to a cooking surface. It is not the cooking surface, it is the heat source. However, you need to bear in mind the gas standard, which also replicates it, and it says until it's changed, or if it's changed, you wouldn't have issues getting the gas turned on if you were not to abide by their reference to the cooking surface. 200 millimetres for a kebab cooker. A salamander has been added to that 200 millimetres. Then there's the examples, as I showed earlier. Use the formula. There's some examples that step through using the perimeter of the open face as the height of the cooking surface and average velocity through the vertical plane. In addition to that, there's a figure being added for the eyebrow hoods. And when you have a multi-stack oven, the height is measured to the middle of the lowest oven. And finally, the WOX, the conflicts in section 3.5, where it referred to 600 millimetres for a cooking surface type, for a cooking process type 6, but the example in Appendix E showed 450 mil. The 600 mil has been retained, but the measurement is from the heat source, so from the edge of the burner. The reason for taking the edge of the burner is because some of the woks have wet decks, and obviously the wet deck's there to cool it, not to do the cooking. So measuring from the edge of the wet deck is not necessarily representative of the heat load. And that brings me to the finish. So thank you very much for listening, and I think we can go to question and answers.
That's fantastic. Thank you, gentlemen. As I started off at the top, you've done a great job of bringing what's a pretty tech-heavy and lots of numbers down to a very well summarised way for all of us to understand that better and easier. So thank you very much. We do have a number of questions. We've got 6 minutes left till 12, so we can run slightly over, but just for the benefit of everyone, we'll run through these with some and answer as best as we can to get through as many as we can. First one, if a pass-through dishwasher requires a hood, if an under-counter was on a stand, would it require a canopy? And is there a way in the new standard to decipher this?
If an under-counter dishwasher was on a stand as opposed to under a counter, it would depend on the kilowatt rating of the dishwasher. If it's less than 8 kilowatts and it's the only thing in the wash-up room, then it would not be classified as type B. If there were multiple appliances in the room, then you'd have to look at the spacing of the appliances and the kilowatt rating of them. If you had an under-counter dishwasher that was more than 8 kilowatts, it would require a hood.
I might just add to that that Section 3 in the standard just has a default minimum amount for kitchens, just at a litres a second per square metre. I can't remember the figure, it might be 5, which we usually use a hood to achieve that anyway, but where there is no hood, there is still a minimum default amount for a kitchen.
Thanks, guys. We've got a couple of more technical ones here. So for the low sidewall hood, item 1, is there a depth front to back for the canopy coverage?
The depth of the hood, well, it depends on the apparatus that's under it. It has a maximum setback. So you can't overhang the appliances because you'd be putting a low hood in the walkway, which will become a obstruction. So it's either got to be flush with the front of the apparatus or set back. And there's a maximum setback of 150 mil. So in the image I showed, or the image that's in the appendix B, it shows the setback is less than, in the case of a fryer, you often have a hob in front of the fryer basket. So typically that setback will be no more than 150 mil. So hence the hood can sit back. It must cover the cooking area.
It answers it perfectly. Where is the height from the cooking appliance to a grease filter taken from? In AS 5601.1, we say the nearest part of the cooking surface or trivet.
Can't really speak on behalf of the gas standard, but it would appear that they took those values from the Australian standard, because the 1350 in the Australian standard is not taken from an international standard. International standards are 4 foot, which is 1216 or 1218. So the 1350 to the source is more than the 4 foot, and that extra distance is to allow for the distance from the flame to the cooking surface. The confusion around flame source to cooking surface, when transcribed into the gas code, they've quite clearly stated theirs as from the cooking surface. And as I said before, you'll run into problems. They won't turn on the gas if their gas code's not met. So from a ventilation point of view, to comply with the ventilation code, you have to do the deemed to satisfy part of our standard, but for getting your gas connected, you have to comply with the gas standard, or put a performance solution together.
Right, so further to the gas, we've got to follow up there. Should there be a reference to combustion products for gas appliances for the type of effluent?
I don't know. Brett, do you have an answer for that one?
I'm trying to read from that question is the types don't take into account the fuel source, whether it's electric or gas. I'm wondering whether there's when selecting the type, it's either as written in the clause there or not specific to it. Not quite understanding the question though, I'm sorry. Perhaps we can come back to that one if there's some clarification.
Yeah, absolutely. There's so on charcoal ovens, will charcoal cooking apparatus incorporating spark arresters now be able to go under shared exhaust canopies?
I'll have a go at that one. That's where AS 1668 Part 1 was revised in 2015 and then amended in 2018 to include additional requirements that didn't exist when 1668 Part 2 previously was updated in 2012. So there are new provisions for fire safety in the updated 1668 Part 1 that address the fire risk. So the question there about needing the separate ducts and the separate canopies and things, that's gone from 2012, but the whole system will still need to comply with the relevant requirements of 1668 Part 2, 1668 Part 1, which includes those spark arresters that you mentioned there. So that is a change.
Right, thank you. In terms of filters, you mentioned carbon and things, but in terms of the use of UV treatment, is there good reference and any changes there?
The reference to UV was only in the commentary of section 3.10.3. And whilst the industry knows UV works well, it's not a quantifiable measure, and as such couldn't be adopted or listed in the deemed to satisfy method because you couldn't quantify it. So a certifier couldn't come in and test it and tick a box and say that's how much it produces, or because it produces different amounts at different temperatures and different humidities and different emissions. So that's why it's not there.
I'd like to add to that, though, that there's nothing to say if further development and quantification can be sourced and obtained, then there's room in the standard to accommodate more and more technologies down this path as we can all get our heads around them. So this was introducing a way of treating effluent in a way that was perhaps quite a conservative way, that was an alternative to heading down the performance solution pathway, which can be costly and time consuming. This is a step in the direction of accommodating some proven technologies. One of the proven technologies that can just help in the design process here. So I'd certainly like to think that further down the track, more technologies can be included in the deemed to satisfy path. But without that being introduced, nothing's changed as far as using other treatment sources and things to create a horizontal discharge, for example. The previous standard required those to be implemented with a performance solution, and that pathway still exists.
Great. Next question we've got here. It's relating to the cooking appliance. Are griddles now considered type 4 cooking process or appliance, a high energy burger fry top? Is there any change around that?
Griddles.
Griddles, yeah. So a high energy.
In the process types, a griddle is considered as a type 2 presently and continues as a type 2. What's been added to type 4 is a flat plate griddle used in high energy, high volume cooking applications where there's a lot of grease. So again, it looks at the emissions from the process rather than the examples. So if you have an apparatus in an application, determining which category it goes into is looking at what are the emissions from it, rather than is it ticking the box of being a griddle or a grill or a char grill, etc.
Question in relation to hoods over combis. I think they mean like an integral hood fitted over a combi. Is there any changes on those with regard to the changes in the standard?
A hood over a combi oven is effectively an eyebrow hood. So if it's discharged out of the room, then it must comply with the eyebrow hood requirements for overhang and heights. There are combi ovens that have filtration systems. So rather than using dilution to outside, they're using filtration to bring the air back to a standard where it can be introduced back into the room and exhausted via general exhaust rather than local exhaust. They would be, I believe, a performance solution that is certified, so they'd get a standard testing and certification for them, so they're sold under the certification.
Electrostatic precipitators, is there allowance for the use of those in this standard?
On their own, it'd be as a performance solution as it has been previously. Although I should say they can be added in to supplement an already deemed to satisfy process with the vertical discharge and all of those sort of things. There's supplementary and additional treatment systems aren't prohibited.
And as far as horizontal use in horizontal discharges, it's the same?
For horizontal discharge, you'd need to do a performance solution as you do at the moment. If you can't apply that clause 3.10.4 for discharges treated to reduce objectionable effluent. So again, it's a step towards accommodating proven practices where there was enough information for the committee to work with on those.
Okay. We've got Enzo who's jumped on here to, I think, clarify a couple. He's got a few questions here in relation to gas appliances. So Enzo, did you want to explain that a little?
Yeah, thank you. Just wanted to point out, first of all, that I chair the AG6 committee that is responsible for the gas installation standard, ASNZS 5601. Before, when I asked the question with regards to making references to combustion products for the different types of effluent, what I was getting at, and I understand, Brett, what you were saying, where it doesn't really take into account the type of appliance, but I just it was more of a statement than a question. It was, should perhaps maybe combustion products be considered when you're categorizing different types of effluent, because obviously there are implications for things like carbon monoxide exposure and so forth. So it's something to think of for the future, I guess, is what I'm suggesting.
Yeah, that sounds appropriate. We need to make sure there's not an overlap between, say, 5601, which is regulated under different legislation and things. I think I understand what you're saying there now. I think the aspects of the combustion products are probably outside the scope of 1668 Part 2 at the moment. But like you say, it's these are the type of things that the industry should be raising, and perhaps with your role in the committee for 5601, there can be a bit of cross discussion between the committees about that for the next revision of either of the standards, and making sure that the requirements are sufficiently clear for the industry to use and work with.
Yep, that's fine.
I'd add quickly, there is in the commentary, there is referral to the gas standard,
Yes.
especially in the area of make-up air and the pressurization of rooms. We put recommendations from a ventilation point of view, put a reference to the gas standard for your requirements for managing carbon monoxide buildup.
Yeah, so 1668 and 5601 aren't two separate options. They both need to be complied with.
Yep.
And if there is any sort of overlap, the most onerous requirement will always apply.
Yep, no, I understand that. And the other one, just very quickly, is I noticed that with grease filter clearances, it's now from the heat source, if I understood correctly. So in clause E71 of 1668 Part 2, 2012, it used to say from the cooking surface, and that's where we took our sort of terminology from. So in 5601, we currently say from the cooking surface, because that aligned with what clause E7.1 used to say. So it sounds like if we want to keep that alignment, the committee that I chair, we're going to have to change that wording to say from the heat source. Am I correct in my summation of that?
Yeah, so the E7.1, the title said from the heat source, and the text said from the cooking surface.
Yeah,
it should be from the heat source, because the increase from 4 foot from 1200 to 1350 was to accommodate that. So if we were going to go from the cooking surface, we'd have to consider the international standard of 1200.
right. And those clearances that are in E7, they still apply, the 1350, the 1050, the 600 and the 200? Yep.
The values have stayed the same. Yes.
Yeah. Okay. There's just one other comment on that. When we say from the heat source, maybe consideration needs to be given to what part of the heat source. So if you've got a gas commercial range and it's got multiple burners and one happens to be a big wok burner compared to the other 4 or 5 burners on the hob, then the heat source, taking it from the heat source, you have to sort of consider, if the wok burner is taller than all the other burners, where is that reference point? So, and I would say it would be from the top of the highest burner, right? If I had to go by the heat source.
From the closest heat source.
Yeah.
Yeah.
Right.
While there's an overlap there, the most onerous will apply.
Yeah.
I'm sure the 1668 committee would be happy to talk to the 5601 committee once the project's underway.
Yeah. Okay. Thank you.
Right, I know we'll run over time, so 2 more quick questions for a lot of people hanging around here. So, very quickly, how is a manufactured ventless cooking appliance that's over the 8 kilowatt measured or deemed to not require an extraction system over?
I don't know.
A ventless cooking appliance
Over the 8 kilowatt.
over 8 kilowatts would be a performance solution.
That's all I'm thinking. It'd have to be a performance solution.
It would follow the path of meeting the performance requirements in the NCC of not causing nuisance or harm to occupants, maintaining adequate internal air quality, and diluting contaminants.
Perfect.
So
And final,
1668 Part 2 doesn't accommodate that approach. Go on, Michael. Sorry.
Thank you. And the last one, in terms of make-up air, I'm looking for clarity on make-up air mixing with conditioned air in reference to J6. By mixing the air-conditioned air with make-up air, the conditioning unit is working harder than it needs to. I've not been allowed to install certain hoods as the front discharge mixes with the conditioned air. Is that an easy one to answer?
I'll start, if I can, just by saying 1668 Part 2 is not an energy efficiency standard. There are some provisions in there that are intended to limit some wasted energy. There is a clause in there around the use of conditioned air and limiting it for the purpose of make-up air. I don't know the circumstances for why something hasn't been allowed, so I can't really comment on that directly. But if there is a requirement in the building code that requires an added level of stringency over and above 1668 Part 2, then the most stringent requirement will always apply.
Right. And so this standard is has been released, but in terms of the building code, that comes in the future but can be applied from now. Is that correct, guys?
As a performance solution, the building code would permit that. There's a lot of work to accommodate that. That is no different to any other new standard that's published at the moment. Before it's referenced, it would be subject to the performance solution process and the acceptance of the relevant authority, the certifier or the relevant building surveyor for the project.
Well done. Well, that concludes with the time that we've got. I'd like to thank you again, Brett and Marcel, for all the work that's gone into making today happen, and obviously all the work that's gone into the involvement and input in creating the standard that it is, as well as everyone else. Thanks to Jennifer for helping put on today, and thanks for everyone joining us and all your great questions. Thank you. We'll see you at the next NAFAS or event. Thank you all.
Thank you very
Thank
much.
you.
Thanks, Marco.